This is chapter 14, question 66. Asking you how many geometrical isomers are there of hex 24 diene. Now this compound is slightly more difficult because it has two double bonds. So what do you need to do is you actually need to um, draw the structure and look at both double bonds. So there are four carbons that we need to look at. Yeah, you know that to have cis trans isomers, the two carbon sharing the double bond, each of them must be bonded to different groups of atoms. Okay, so I'm drawing the structure now for carbon number 1 and 2. Okay, followed by 3 and 4. Yep. Because one of the answers say that it does not show geometric isomerism, so we want to confirm that first. So we look at carbon number 1 and number 2. So each carbon is bonded to two different groups of atoms. So the first, okay, the first double bond, the two carbon, can show cis trans isomerism. Now let's look at carbon 3 and 4. So each carbon also bonded to different groups of atoms, right? Also can show cis trans isomerism. Okay, now how many pair of cis trans isomers? You see, this is actually a bit like finding the probability for, in mathematics. I can have this combination. I can have between 1 and 2, right? Cis isomer. Okay. This one is a trans isomer. Correct or not? Now, if I draw different structure, I change the position. Okay, I can get cis here and then also cis on the other double bond. Okay. Or I can have trans and trans. Okay. Or I can have trans and cis. But the answer is only three pair. You see, if we find different combination, we should have four, right? But the answer is three because cis trans and trans cis, if you draw the structure right, they are actually the same. So let's try to, this is cis and trans. Let's try to draw trans and cis, yeah, and see whether they are the same or not. So I change the left hand side from cis to trans. Now I need to change the right hand side one from trans to cis. Okay. Now, so these two, yeah, this is cis and trans. This is trans and cis. But can you see that if I flip this molecule, it will look the same like this molecule. So cis trans and trans cis molecules, they are the same. So we cannot consider them as two different isomers. So the answer is only three pairs.